Okay, question 1a is on factor theorem. Okay, so it says, well, factor and remainder theorem. So it says the remainder when f of x is divided by x minus 2 is equal to the remainder when f of x is divided by x plus 1. Okay, so we set this equal to 0, that gives us x equals 2. And if we set that equal to 0, that gives us x equals minus 1. So we sub both these in and set them equal. Okay, so we say f of 2 is equal to f of minus 1. So this is remainder theorem. Okay, so now we can substitute the values in. We've got 2 to the 4 plus 5 times 2 to the 3 plus a times 2 plus b equals minus 1 to the 4 plus 5 times minus 1 to the 3 plus a times minus 1 plus b. Okay, so b's cancel straight away, and then our next line is, this is 16 plus 40 plus 2a is equal to minus 1 to the power of 4 is 1, and minus 1 to the power of 3 is minus 1, so we get minus 5 minus a. Okay, so now we can add a to both sides. And then on this side we get 3a, and we can also take away this, which is 56, from both sides, and that will give us 3a is minus 60, therefore a equals minus 20. Okay, now given that x plus 3 is a factor, so we're using factor theorem, so we set this equal to 0, and that gives us x is minus 3, and then we know from factor theorem that f of minus 3 is equal to 0 because it's a factor. So let's substitute that in. We get minus 3 to the 4 plus 5 times minus 3 to the 3 minus 20, that's our a that we worked out in part A, times minus 3 plus b equals 0. Okay, and so if we expand these we get minus 135 plus 60 plus b equals 0, therefore b equals minus 6.